Okay, activity 1.2, investigating reflections. In this activity, you will use patty paper to search, no we won't, to search for specific patterns on the coordinate plane, reflecting across the x-axis. Okay, so this is the x-axis, so we're reflecting across the x-axis. So this is the one that says x, so this is the x-axis. The other one is the y-axis. Place a sheet of patty paper over the coordinate plane and trace the axes. For each pair, plot and label the point on patty paper. Fold the patty paper on the x-axis. Trace the point through the patty paper. That's the tough one. Label the coordinates of the new point. Okay. I was just thinking about this, and I want to try to see if I have something that would work like this patty paper they're talking about. One moment, please. Ho, 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 ho. This might just work. All right. So, place the sheet of trace the axes. I want this one, and then I want this one. Okay, but we're going over the x-axis. Plot and label the point on patty paper. So the first point here was A, which is 4, 1. So I go to 4, I go to 1. Okay. Then it says fold the patty paper on the x-axis. Well, the x-axis is the one that says x on it. So we fold it over there as best as we can, which is trickier than you'd think. And so it's right about there because that's 4 and that's 1. And now trace the point through the patty paper. Well, I can see where it is. Instead of being 4, 1, 4, 1, now it is 4, negative 1. And so that's what I'm going to write down. 4, negative 1. Okay. Notice how there's that little symbol right there. And that says that A blah is read as A prime. So it's like the opposite of it. Okay. So it's just saying so this and this are different because this is A and then this is A prime. This is B prime. This is C prime. This is D prime. This is Optimus. This is Optimus prime. All right. And so it's like the next one. All right. So we do that with the rest of these then. So now we put this over there with the patty paper. And then B says I need to go to -3 and then 4. So I go to -3 and then I go to 4. Then I fold it over the x-axis. And when I do that, I'm at -3, -4. Okay, so I'm looking for the patterns there that are happening. Next one is C. And C, I go to 5 and then 2. So I go over to 5 and then I go to 2. Once I'm at 5, 2, then I fold it over the x-axis and I would be at 5, -2. 5, -2. And then the last one that we have here is 0 and -7. So I want to go to 0 and then -7 all the way down there. Then when I fold it over the x-axis, it would fold up this time, and it would fold to 0 and 7. Ooh, I did C wrong, didn't I? C was my fault. Look, C was 5, -2. 5, 5, -2 would fold up to be 5, +2. My bad. I did that wrong. Okay. So look at these. A was 4, 1. A prime was 4, -1. B was -3, 4. B prime is -3, -4. C was 5, -2. C prime was 5, +2. My fault. D was 0, -7. D prime was 0, 7. So what did you notice about the coordinates of the original points and the reflections? Write a generalization for how the coordinates of a point and its reflection across the x-axis are related. The x-coordinate, the first number, stayed the same while the y-coordinate, the second number, changed its sign. Either from negative to positive, or from positive to negative. Okay? And so we are reflecting. That means we're bringing it across. And so that was an example of reflecting across the x-axis. All right. So now we're going to investigate reflecting across the y-axis. Place a new sheet of patty paper, haha, wax paper just like patty paper, over the coordinate plane and trace the axes. Probably saying that wrong. Someone's going to correct me. Maybe I'm saying it right. That's okay too. X is this way, Y is that way. I want to get used to that. All right. For each ordered pair, plot and label the point on patty paper. Fold the patty paper on the y-axis. So the y-axis is this one now. Trace the point through the patty paper. Can't quite do that. Label the coordinates of the new point. Okay. So A now is 4, 1. So hopefully I do a little bit better with this. So I go to 4, I go to 1. Boom. 4, 1. Then now I need to fold the patty on the y-axis. So I don't need to go on the x. I need to fold it on the y-axis. I'm folding it on the y-axis. And then if I've done it correctly, which I'm fairly close to doing, I would now have -4, but it's still 1. And so that is what happens there. The first coordinate switched from a positive to a negative. The second coordinate, the y coordinate, stayed the same. All right. Second one. I'm going for B, and B is -3 and 4. So I go to -3, and then I go to 4 right there. Then I'm going to fold it over the y-axis. Once I do that, I can see that I am now at +3 and 4. So again, the x-coordinate switched from a negative to a positive. The y-coordinate stayed the same. It stayed as a positive. It stayed exactly the same. Okay. Now C is 5 and -2. And now I fold it over the y-axis. And so it becomes over here -5, -2, -5, -2. Again, the x coordinate is the opposite. And oops, did it again. And the y coordinate stayed the same. Last but not least, I go to -3 and 0. So I go to -3 and 0 right here. I fold it over on the y-axis, and then it becomes 3 and 0. Okay. What did you notice about the coordinates of the original points and their reflections? Right, a generalization, like what's true all the time, for how the coordinates of a point and its reflection across the y-axis are related. The x coordinate changes its sign from positive to negative or negative to positive. Okay. The y coordinate stays the same. All right, your teacher is going to select students to plot ordered pairs that meet specific conditions. No, I'm not. The students will select locations that satisfy those conditions. For each student, plot and label the point where the student is standing on the coordinate plane. Then record the coordinates of that point in the table. So what I'm going to do is I'm going to put 3 points on here. The first point I'm going to put on here is going to be a point in quadrant 2. And so the point in quadrant 2 is going to be right there. And that's going to be A. I want you to pause, and I want you to write down that point down here in quadrant where it is. Now, B says it is a reflection of A across the x-axis. So if I'm thinking about this, here is A, here is the x-axis. I can see the x there, so I know it's the x-axis. It's a reflection of A across the x-axis means if I'm taking it, I am going down with it until it gets to that other point. And then down here, A was -5 and 6 for its coordinates. B, which is right here, would be -5, -6 for its coordinates. Now I'm going to put -5, -6 right there for B, and then I'm going to read C. C says reflection of B across the y-axis. So if I'm looking here, put my y-axis on my wax paper, and then I do a reflection of B, so I make sure I have B on there, and I do a reflection of B on the y-axis, then I see that C would be in this new point right here, which is 5, -6. And so I'm going to make sure I have the 5, -6 here for C. Okay? And so when we went and reflected over the x-axis, notice that the y-coordinate, the second coordinate, changed. When we reflected over the y-axis, notice that the x-axis changed from its sign. Okay? And so it's like whatever axis we're flipping it over, the opposite axis is what changes its sign. Compare the ordered pairs for A and C. What you notice about their coordinates. So from A to C, this one's the opposite, and this one's the opposite. So from A to C, both the x and y coordinates are the opposite. Write a generalization for how the coordinates of a point and its reflection across both axes are related. When you reflect a point across both axes, both coordinates x and y will be the opposite sign, from a positive to a negative or a negative to a positive. All right. For each pair of conditions, plot and label 2 points. Record the coordinates of the points. One point is in quadrant 2. The 2 points are reflections of each other across the x-axis. So, if I think about this, 1 point is in quadrant 2. I know this is quadrant 1, then it's counterclockwise. That's quadrant 2, that's quadrant 3, and that's quadrant 4. So I know 1 point is in quadrant 2, and it's kind of like you can choose your own point, but I'm going to choose -1, -1, and then I'm going to have it be in quadrant 2, so it'll be 5. And so -1 and 5. And I will call that one A prime. Then, if I reflect it across, the 2 points are reflections of each other across the x-axis. This is the x-axis. So if I flipped it over that, then, so that would be A prime, and then this would be A. And A over the x-axis would be -1, -5. When I flip it over the x-axis, the y-coordinate changes. Okay? Then I'll switch it to this. B, one point is in quadrant 3. So now I'm going to make it so 1 is in quadrant 3, so somewhere down here. And I'm going to make that one be -5, -4. And so we'll call that one B. And that was -5, -4. Now they want you to make it so the points are reflections of each other across the y-axis. Well, here's the y-axis right here. And so I'm flipping it over the y-axis, and then it would be over here on this side, and it would be right here. And so if this was B, then I'm going to make this one be B prime, and B prime would be +5, but it's still -4. So when I flip it over the y-axis, the x-coordinate changes its sign. Sorry. Last one. Ooh, I need to get a third color. Uh-oh, 1 second. All right. So now one point is in quadrant 4. So for quadrant 4, that's this one down here, we will have to go to 2 and -6. And we'll call that one C. So C is going to be 2, -6. Now the points are reflections of each other across both axes. Ooh, this is a tricky one here. So C prime, I need to flip it over the x-axis. So I'm going to flip it over the x-axis first. And so when it gets over the x-axis, when it flips up, then it would be at 2, and it would be at -6, so it would be right there. But then I need to flip it over the y-axis, so I flip it over this side, and then it goes right over to here. And so then I would have as my answer here, oops, sorry, oh no. I flipped it over the x-axis first to get to here. Then I flipped it over the y-axis to get to here. And so this is where C prime would be, and this is -2, 6. -2, 6. Okay? In general, how are points that are reflections across one or both axes similar to and different from each other? Okay? So let me see here. Points that are reflections across one or both axes differ only by the signs of the coordinates. Right? Like the numbers aren't changing. It's just it's going from a negative to a positive or from a positive to a negative. In fact, I could get more specific here. When I'm going across the x-axis, the y-coordinate changes its sign. When I go across the y-axis, the x-coordinate changes its sign. When I go across both axes, both coordinates change their sign. Okay? And so we've been practicing reflecting points across the x-axis and the y-axis today.